3, topic 3.4, problem solving. We will first look at the solve problems from the slide, and then we will work on in-class exercise 2 of chapter 3. So given the four forces as and the geometry as shown, so there are four forces. One, which is the weight, 300 pound or applied force. Then there is force in cable AB, force in cable BC, and force in cable AD. And we need to calculate the tension forces developed in these three cables. So these are our three unknowns, 1, 2, and 3. For this given 300 pound force, what will be the forces in these cables? It's a three-dimensional force system. So we will follow this plan. So we will draw free body diagram for particle A, write the unknown forces in Cartesian vector form, and apply equations of equilibrium. So here is the free body diagram. All the forces are being shown. And then each force is written as a Cartesian vector. For example, force acting along B is only acting along positive direction. So its magnitude is TB, that is tension in cable B, multiplied by its direction is I for the positive direction. Similar to that, tension in C and D are three-dimensional forces. So we need to project them along X and Y and Z respectively. So for TC, first we project this TC along XY plane, which is TC cosine 60. And then we further apply this angle here, that is cosine of that angle, and multiply that, and we will get the Y component of TC. So that is TC cosine 60 multiplied by cosine 30, sorry. For X component of that, we have to apply sine of that angle because angle is given between the projection and Y axis. So cosine closes the angle, so this will give us the Y projection, and X projection of that will be in this direction, which will be TC cosine 60 multiplied by sine 30. And Z projection of TC is easy because it can directly projected using this angle. So TC sine 60 gives us the Z projection. So this is X projection, which is negative because it's going in the negative direction, positive axis here. This is Y and this is Z. So that's the final TC as a Cartesian vector form. And TD is written in the similar way, and the W is acting down along negative Z direction. So this is positive Z direction. So W is minus 300K. So we have written all the four forces as Cartesian vector form. And the next step is apply equations of equilibrium. That is sum of all the forces is equal to 0. That is each force we have written here as a Cartesian vector form. And the next step is we separate this Cartesian vector form into scalar equations. So X component of all the forces, that is TB plus TC plus TD, only X component, that is equal to 0. So now since it's a scalar equation, we do not use I, J, K components because direction is defined by X, Y, and Z respectively. So only the multipliers, not directions, only the magnitudes. So that is equation number 1. Similar to that, adding only Y components, which is TC multiplied by 0.433, TD multiplied by minus 0.5, and that's equal to 0. That's number 2. And third equation is this TC multiplied by 0.66, TD multiplied by 0.7, minus 300 equal to 0. So we have three equations, and our three unknowns are 1, 2, and 3. So using three equations, we can solve for three unknowns. Okay, and here are the magnitudes. So let's apply this to in-class exercise 2. So chapter 3, in-class exercise 2. Problem number 3.44. It's a three-dimensional force system. Now for three-dimensional force system, we will apply the vector equation first. We will write all the forces as vectors using I, J, K components. But once we have the final equation with all the forces as vector, we will separate that into three scalar equations. And that is the approach we follow for a three-dimensional force system. So in this case, well, if it is all the forces are in 3D, however, for this particular problem, even though it's a three-dimensional force system where we have X, Y, and Z axis respectively, none of the forces in actual 3 dimension. All the forces are only in one plane. For example, FA is only along one axis, F3 is only along negative Z. This force is only in XY plane. F2 is only in YZ plane, and this 4 kilonewton is also only in XY plane. So there are literally each force is 2-dimension, even though the actual coordinate system is 3-dimension. So let's apply equations of equilibrium. We can use scalar solution here because none of the forces is real 3-dimension force. So let's say apply equations of equilibrium at this free body diagram. Sum of the forces in x direction equal to 0. So let's say which forces have x component. So F1 has x component, which is pointing in positive direction. So F1. Then this 4 kilonewton has x component, which will point in the negative direction, which is 4 sine 30. So 4 sine 30 will give us the negative x component of that. So F1 minus 4 sine 30 minus this force has x component, which will also point in the negative direction, looking at this diagram. So that x component is nothing but x-axis is parallel to this side, which has magnitude 7, divided by the longest side 25 multiplied by 10. So this is 10 multiplied by 7 divided by 25. And these are the only forces, and that's equation number 1. In fact, from this equation, we can easily solve for F1 because F1 is the only unknown, so that's 4.80 kilonewtons. Sum of forces, so that's our first answer, in y direction equal to 0. So for that, we have F1 does not have any value in y direction because this is along x direction. This 4 kilonewton has y component, which is 4 cosine of this angle 30, and that will point in the negative y direction because this is positive y direction. This is positive x direction, and this is positive z direction. So this is 4 cosine 30 will be pointing here. So it's minus 4 cosine 30. Minus F2. This force has y component that also points in the negative direction. So minus F2 cosine 30. This angle is also 30 degree. Plus y component of this 10 kilonewton, which will point in the positive direction. And this line is parallel to y-axis. So it is 24 divided by 25 multiplied by this magnitude. That's equal to 0. And the only unknown here is F2. So we can solve for F2, which is 7.08 kilonewtons. That's our second unknown. And third equation, sum of forces in z direction equal to 0. So for z-axis, we have, so F1 is not along z-axis, F3 is along z-axis, which is negative, but we will have the component of F2 that will be positive. So F2 sine 30 will be along positive z-axis, and that's this projection. Okay, so there are only two forces, F2 sine 30 and negative F3. Okay, and from that we can solve for F3 because we already know the value of F2 from the previous step, so that we can substitute here, okay, and solve for F3. So F3 is 3.54 kilonewtons. So we have solved for all three unknown forces. Determine the magnitudes of F1, F2, F3 for equilibrium of the particle. Now there is another problem in the in-class exercise, which is 3.48. So for this problem, what you need to do is there are four forces here: force in cable AB, force in cable AC, force in cable AD, and force acting because of the weight of the box. Now weight of the box is 100 kilogram, mass of the box is 100, so its weight is 100 divided by 9.81 acting down. and for each one of this force, the force is going away from A. So this is the direction for AB, this is direction for AC, and this is direction for AD. And to write down each force as a Cartesian vector, we need to first calculate the position vector for each one of them. So we need the coordinates of each point, and write down the equation for the position vector, divide the position vector by its magnitude, and multiply that with the magnitude of the force. Now we do not know the magnitude, so we will use variables for that. So we will call this TAB or FAB, we'll call this TAC, and we will call this TAD. And then write 3D Cartesian representation for each of these forces, and then later and add them together, the resultant force is equal to 0, and then separate this into I, J, and K component equations, that is for X, Y, and Z axis respectively, and solve for the unknowns. So this problem is very similar to this problem, except that it's just a different diagram. Okay, so apply the same approach as you have applied here for this problem solving, and then compare your answers like with the solution that has been provided to you.